So we have a roller coaster with a height of, 200 meters. And we want to get the speed of the coaster at the top of the loop if the radius is 20. So let's be clear. This is 200 meters. The radius is 20. And let's be clear on something else. The height here, this is actually 40 meters worth of height for the loop at point B. So we want to get the speed at the top of this loop here. We want to know what that is. And we want to figure out that based on the fact that here we have only gravitational energy and no kinetic energy. So let's actually set up our energy equation. E initial equals E final. And so that is given. Here's what you have to figure out, though. You have to realize that we have gravitational energy on the left side with no kinetic. And on the right side, when we actually get up to the top of the loop here, we're going to have a new gravitational energy plus some kinetic energy since it's moving. Now, one thing I want to note is that I can actually divide both sides by m and it cancels out. So be careful when you can do that. You need to know your rules of algebra. So we're going to have 10 times my height, which is 200, equals 10 times 40 plus v squared over 2. So we end up getting 10 times 160 equals v squared over 2. So v squared equals 3,200. And when we actually solve for v, we end up getting, this is really fast. Okay, let's just be clear. This roller coaster probably violates any and all safety standards and is illegal, but that's okay. So 56.6 meters per second. One thing I want to note, notice v squared is 3,200, v is 56.6 meters per second. I'm going to use this fact in the next problem. So we want to know the normal force on the roller coaster at the top of the loop if its mass is 500 kilograms. So we're at the top of this loop. Let's draw a free body diagram. So we're going to have normal pointing down and weight pointing down. One thing, we didn't say that we're at the minimum speed. We're actually at the speed here, which is not the minimum speed to make it around the loop. It's actually slower. So we have weight and the normal force, and the effect is that the roller coaster goes in a circle. Again, this is MAC here. I'm just plugging in v squared over r. So we have mg plus normal equals mv squared over r. Let's continue with the math. So 500 times 10 plus the normal force equals 500 times v squared is 3,200 and r is 20, so this cancels. So we end up getting 500, so 5,000 plus n equals 500 times 160. I'm not sure, but I think if people ride this roller coaster, they're going to pass out or die from the normal force. So we'll just kind of, so we're getting, looks like we're getting a force of about 79,500 newtons. So I think riding this particular roller coaster would actually, in fact, be a fatal experience, but we're going to ignore that fact. Now, what is the minimum speed to get around the loop? We're going to use the same idea that we did before. So we'll copy all this physics here. And what we'll note is that the normal force is 0. So we have mg equals mv squared divided by r. The m's cancel, so we have 10 equals v squared divided by 20. So v is the square root of 200. So I'm getting a minimum speed of about 14.14 meters per second. All right. Now, for this one, I'm going to actually have you try to solve this on your own, but here's what I want to ask you to do. On this part here, if you want help, I need you to solve or attempt take a photo and email it to me. I'll need you to do this. This is kind of a check to see if you're checking the PDF solutions or the videos. And this is going to be very cryptic, because if you don't look at the video solutions or you don't look at this PDF, you're not going to know this. And so you've got to kind of look for this. I will not be giving help on this part unless I see you attempt a solution. You have to try this, okay? And I will give you feedback, but only if you send me a photo, all right? So that's question 4, and that's it for the practice test.